project is integrating Gemstone with macOS 10. So I'm going to quickly run through macOS 10 and how it's built and Cocoa and all those things, but I'm not going to dwell too much on it. You're going to see some Objective-C. I'm sorry. There's more syntax than we would like, but bear with me. So macOS 10, like I say, the programming language is Objective-C. This is your main interface to the system. You can do stuff in C, but really Objective-C. Louder? Oh, sorry. Sorry. Okay. So Objective-C is the main blessed programming language of macOS 10. It's how the vast majority of applications are built. You can do stuff in C, but the main APIs are all in Objective-C. The two primary libraries that you deal with, Cocoa is all the sort of base libraries, the application libraries. Foundation is where you find all your strings and files and whatnot, and Application Kit is all of your graphical user interface stuff. So the good things about Objective-C, and this one's going to be controversial, it's a superset of C. What that means is calling any C library, calling any C code, it's not just easy, it's C. It's the exact same ABI and everything works great. And there's a lot of libraries out there written in C. So this is nice for interoperability. Smalltalk message passing semantics. The class model and the message passing are modeled on Smalltalk. It's single inheritance. They have the concept of protocols, which is really just like interfaces in Java. But the message passing is basically Smalltalk. It's message return. Class extensions. This is great. Anybody who's done C++ or Java and wanted to add a method to a class they didn't have the source to knows how great this is. In Smalltalk, you do this without even thinking about it. In Objective-C, you can also just go ahead and add methods. Optional compile time type checking. This means if you have a string and you try to pass a message to it that string doesn't respond to, it'll warn you. It's not an error. You can still go ahead and send the wrong message. It'll let you do that. It's dynamic enough. But it'll warn you. And since I don't pay a lot of attention half the time, that's nice. The bad stuff about Objective-C, not everything's an object. This means you're still dealing with integers and floats and pointers and structs. Some of the foundation stuff in Cocoa are structs. You have rectangles and points, and all of these things are structs, and they're not objects. And annoying. Blocks were added to their C compiler in 10.6. They actually added blocks to the C language. They went and changed C language, which I didn't think you were allowed to do. But they went ahead and did it on their own. They added blocks. So until then, you were dealing with standard C control structures, and now you have something more interesting. They mostly use this for multi-threading. Garbage collection is optional. If there's any Mac programmers in the room, turn on garbage collection. Don't just stop. Forget release and retain, because right now we still have to do manual reference counting for all the people that insist that garbage collection is bad and is slow and it's great. Turn it on. Become. There's no become. Especially for somebody like me who's building proxy classes and libraries and would love to load things lazily, it would be really nice to have something like become. But because objects are allocated directly in the heap, if the new object that you want to become is bigger than your old object, you can't do it. So they just don't have that capability. Cocoa, what's good about Cocoa? Well, it's pretty. It has well-designed views. They're usable. They're constantly adding new stuff to the views that you have. They've added spell checking to the text view. They've adding gestures to scroll around. It's a nice UI library. Interface Builder is the secret sauce of macOS 10. Interface Builder, come on. Interface Builder lets you very quickly build up user interfaces. You frequently don't need to ever do any manual sort of widget manipulation in your actual code. You just build your controllers and classes behind that. And we have core data for local applications. What core data is their way of serializing an object graph, but it's gross. It's object relational, or it stores it to XML or a binary blob, and it's local only. So it's great for desktop applications, which is their bread and butter, and it's where they put all their efforts. But it's not so good for people who need their applications to talk to each other. And so the bad, there's no network-ready data store. Now, it just so happens that there exists a network-ready data store that has Smalltalk-like message passing semantics, and that's Gemstone. So the goals of the Gemstone kit that I'm building is make Gemstone object instances first-class citizens in the Objective-C runtime. Now, for now, I'm saying object instances because I don't replicate Gemstone classes in the Objective-C runtime. I just proxy the instances. This may change in the future, but for now, it's just there's only one class, which is the proxy class, and it just packages all the messages and sends them across to the Gemstone gem. Be simple. Being simple, I've put before being fast. In fact, being fast is not on the list. I want all of the macOS 10 user interface technologies and all of the macOS 10 they have a bunch of different things that work with their object system, and I want those to just work. And in some cases, that might cost a little more memory or a little more CPU usage or time or whatever. So obviously the first thing that you build when you're doing anything with Smalltalk is a browser, right? Because if you don't have a browser, what's the point? So this is not functional, but it does expose a lot of the functionality. And what you're seeing here is the standard Gemstone 64-bit version 2. Whatever, the latest one. And it's a usable browser. You can browse through stuff. If I... Hang on. I don't remember my own shortcuts. So this is not really a debugger. It's more of a stack trace shower. But it does let you see the stack trace and lets you see where the error has occurred. So all of this is built with the stuff that I'm talking about, where you just package up Gemstone objects as though they were Objective-C objects and access them directly. The syntax highlighting, by the way, was stolen from Shout, so thanks, Shout. And then redone in Objective-C. Typical, just very simple usage of the Gemstone kit. You get a connection. Obviously, you declare types in Objective-C. Connect to a stone. These are the standard, the C-side one that you download and install on macOS 10. Here, what I'm doing, the @ symbol, for those who haven't done Objective-C, the @ symbol is just specifying that it's an Objective-C string instead of a C character pointer. So I'm just saying, hey, Gemstone, execute this code. Ice cream is gelato. Probably one of the most useful associations on the planet. And this will return a proxy object that represents this association in the Gemstone, in the gem, because it hasn't been put in the stone yet. You haven't committed anything. So the key would return ice cream, the value would return gelato, and it would return Objective-C strings in this case, and I'll get to that in a second. The class is going to be GSProxy. GSProxy is this magical class that forwards all the message sends to the gem. However, we're in Catalonia. So a much more useful association to know about is that helado should be said gelat. Anybody in the audience who speaks Spanish? Gelat, very useful. So here I'm setting the key to helado and the value to gelat. And if I ask for the display string, it will return helado, gelat. Not a thrilling example, but it's an example that this looks like any Objective-C code. The message sends are transparent to the user. They're not worrying about garbage collection. They're not worrying about objects falling in and out of scope because that's all handled by the library behind the scenes. Some notes about the implementation. Immutable types are copied. This means strings become NS string. Number becomes NS number. Oh, I think strings actually can be mutated in Gemstone if you do something special to them. So if you're using this, don't do that because I won't know about it. And Booleans become NS number because Apple or Next, in their infinite wisdom, doesn't have a Boolean class. This is really, really irritating. You get numbers and you don't know where they came from or what they do unless you have the original definition of the class. This is a sticking point. Collections are wrapped specially because collections are so frequently used in UI that it's much better to have them responding to the interface of the Objective-C class. So a dictionary is wrapped in a GS dictionary. Ordered collections are wrapped in GS array, and it goes by subclass, which could be dangerous if a subclass behaves particularly strangely. But this is so far it's working. All other objects for now are GS proxy. GS proxy is the magical message forwarding class. So I wanted to do a demo, of how you would build an application with this library accessing data that's stored in Gemstone. So I don't know how many of you have seen the wonderful seaside application, the sushi store. I just picked this because the data is already there and it's relatively simple for us to quickly access. So this is, you just have a list of sushi stored in a singleton. So I'm going to create it, start it completely from scratch. Now there's a weird little step that I have to take here because I don't have the framework installed as a system-wide framework. I just bundle it into the application, so there's some things I have to do. Let me just check for a minute. So here I'm pulling in the kit, the actual framework. And if this was a system-wide framework and you had it installed, a bunch of these steps would be unnecessary. You would just say, I want to link against the Gemstone kit, and it would find a version at runtime. If there was a newer version or older version, the framework stuff in Mac OS X is fairly sophisticated. Target sushi. So I've actually written all the code, which there's not much of, but I didn't think you guys would want to sit here while I while I type this stuff out again. Compiled. That's weird. So the interesting stuff, which at least what I think is interesting, is this interface builder technology that they have, which is very slow to start. So there you go. Interface Builder just manages a graph of objects, and in general those objects are graphical views. There are tables and labels and whatnot, but you can also manage non-graphical components, and this is exactly what we want to do here. We want, lost my window, I'm dealing with a little screen here. So over here, I can just add any object to the interface definition. When that interface is loaded, that object will be created for me and all the connections will be done. What I want this to be is the sushi controller, which is the class that I've already written, which we'll actually take a look at now. And the sushi controller, the only thing that I do here is your class responds to awake from nib. The nib files are the interface builder files, even though they're not actually nib files anymore. Now they're zibs or something, XML instead of binary. So all I do here is I have a connection, which is just a single global variable. I tell it to connect to a stone, and I tell it to set fishes, which is an instance variable, and it's to the result of this code. WA store inventory, default all items. That's just the ordered collection of WA item classes, which contain the sushi and their name and their name in English and their price. Now it's all model view controller technology, but nope. Sorry about that. It's all MVC, but what they've done is they've abstracted away a lot of the controllers that you might need to build. So here they have a stock array controller, which you can just add to your application and tell it using a binding. And bindings are, again, these are things that are set at when you instantiate the interface, it will set all these connections between you. So here, if we just bind it to, oops, what do I have to bind to? Sushi controller, fishes. And now our data is in a controller, we're ready to start actually filling out the UI. So we want a table. And a text view. And they have all these nice, their UI is there's no grid bag or constraints or anything like that. They just let you fix how you want the objects to resize based on whether they'll be anchored or not. Just double check that I got all this right. Yeah. Oops. And they help you with alignment, which is slightly fascist of them, but. So here, again, using bindings, text field cell, table column. Again, using bindings, we bind to, let's name this something a little more descriptive. So we bind to the controller key arranged objects, which is going to be an array of objects or something that implements the array interface, sorted by the sort order that the controller is keeping things in. So it will give you sorting for free, and it'll give you, I think it can give you filtering as well. And here we want subtitle. Yeah, if I got this right. So that's it. That's a read-only. That's all you need to do to get an array of objects into a table view and displaying in the table view. We're not done though. Now the array controller also has the concept of a current selection. So in the text view, simply by binding to the fishes controller section, and here is where we get into some weird magic. The _GS underscore is because description is sometimes implemented by certain classes in Objective-C, but I want to make sure that it gets sent through to Gemstone. I don't want the Objective-C description. So I just prefix it with _GS underscore, and the library knows to strip that off and send the message. Right? So if anybody defines Objective-C classes with _GS underscore methods, well, I don't know, you have to double them up, I guess. So without having to build any sort of any event handling or anything, we've already got the text view filling out automatically with the description that's stored in the Gemstone server. Checking my notes. A slightly more advanced example that we can look at is the prices. Now the prices in the Gemstone server are actually stored, again, they're stored with the class. Just so this, as you can see, they've stored it as pennies. It's the number of cents that particular piece of sushi is going to cost you, which isn't so nice to display to the user. Fortunately, they've thought of this, and what we have here is a value transformer. The value transformer will take, it can be a one-way or a two-way transformation on the value simply before it's displayed to the user. It doesn't change the model in any way. And so here I've got a class-defined pennies to dollars transformer. I'm not going to explain this code. It's divide by 100 and then multiply by 100. So now we have it displayed as dollars, but it's still not formatted very nicely. And then they have the concept of a formatter, which modifies a text view. So simply by adding a number formatter to... Did it add it? Yeah, it's there. Hang on, I seem to have lost my formatter. There we are. So here you have a ton of control over the formatting style. I'm going to say that I want currency, but then I'm going to change this to the $sign, because otherwise it's going to show up as euros. Great. So now we have the price displayed. Again, that was, it took me an extra 3 minutes instead of the very simple thing. But you can see that we already have a fairly usable read-only interface to objects that are stored in Gemstone. But it's read-only at the moment, and that's not particularly interesting. So what I've done to be able to work with these is where we have the NSArray controller. I've actually built a subclass of this called GSArray controller, where I can specify. Now, the reason I use entity here, this is normally used with their core data technology. And the reason I use entity instead of class is because the class doesn't really exist. It only exists in the gem. It doesn't exist in the Objective-C runtime. So if I try to allocate a class, whatever class I put there, it's going to fail. But by lying to it and telling it that it's an entity, then my subclass can look at the entity, which happens to be a string. So here I think it's WA store item. And we want the typical sort of thing to edit a for some reason, if you add toolbar buttons directly to a toolbar, interface builder crashes. So don't do that. You have to add them to the general object first, and then you can put them in. It's weird. So I'm going to want a new button and a remove and a delete. Nope. Did I say remove and delete? I meant commit and delete. Sorry. Delete. And of course, because everything in Gemstone is transactions, we need a commit button. And I've even got, give me 1 second here. Add those by default. So they're there now, and now it's just a matter of binding them to correct action so that they actually do something. Now the controller will take care of adding and removing items because that's all built into the Cocoa controller system, but obviously committing, which is something outside of their sort of scope. They don't know how to do that. But here, so we add, and we add, delete will be remove, and then commit I've had to implement myself in the Sushi controller. And all that does is pass on the commit to the connection that I've created to Gemstone. So by default, adding a new one just creates an empty object in its sort of default state. It just calls new. This isn't particularly thrilling, so you sort of have to fill it out. Oops. So if we go back to C side, we can see that in fact it's been added. It's not sorted, sorry. I don't know why the description didn't get added. There we go. So this, I think, shows that you can very quickly build up a user interface using Interface Builder. Very doubtful. And with this library, the objects that you're manipulating can be sitting in a Gemstone server, which is something currently completely missing from Apple's set of technologies. They don't even have a standard object relational mapper to access Postgres or Oracle or whatever it is you want on your back end. So any application that needs to do this kind of work has to reinvent the wheel. So this is my wheel. Just delete that. So getting back to it. Unresolved issues that I have so far. The Boolean values. Objective-C can't tell a Boolean from a number. And the total lack of interest that anybody has in this. No one's building. Macs have been sitting outside the enterprise for a solid decade now and are slowly worming their way back in, and maybe people care, but honestly, most of the interfaces that they're doing for this will probably be web-based. They'll probably just use Safari. It's a great web browser, and if you just give people a web-based interface, they can get their work done with this. I think that's a terrible way to make people work. And I think web-based interfaces are awful and inefficient. I think they're great for client-facing stuff, and I think that if you're trying to be genuinely productive, you should have a real UI. But that's just me. And I also happen to think that Cocoa is one of the better toolkits out there for building user interfaces. Hence, my project. Future features that I would like to add to it. Those are supposed to come up one at a time. Obviously, my keynote foo is pretty lame. Multi-user change notification. I would like to have it automatically propagate changes to the object set to any other client that's currently viewing those objects, so that if you have two people editing sushi at the same time, the changes automatically propagate and show up. And this should be possible. Gemstone does it, and Cocoa does it as well. Automatically persisting Objective-C classes, I think, could be really compelling, but not to anybody in this room. Mostly to Mac developers who want to just define their Objective-C classes and have those automatically turned into Gemstone classes just with stupid getters and setters and instance variables, and have the whole graph persisted in Gemstone seamlessly without having to think about redefining it in core data or persisting it to Postgres. The third one, I'm not sure about, dynamically creating Objective-C proxy classes. Like I said, right now when I pull in instances, they're all wrapped in the same class, this proxy class, which is fine 90% of the time. But if you're doing any kind of introspection, you're not going to see all the methods available to it. You're not going to know the instance variables. There's knowledge hidden from you in that case. And the weird thing is, even if you pull a class over as an object, it's still wrapped in GS proxy. So you can be doing stuff on a class, and it's an instance of GS proxy still. And the last one is Magritte. I think it would be really interesting to dynamically generate all this stuff, which is still possible. Like I say, this is just a graph of objects stored in a file, and there's nothing that prevents you from dynamically creating them and adding them in the hierarchy. And so if you wanted to build something like Magritte, you could very easily say, okay, well, for these classes, build these classes in the Objective-C world and fill out a user interface. So that's possible. The last thing is, I don't know if any of you know FScript. Yeah. So a weird little thing that I managed to get working after some fighting with them. This is actually where that GS description thing came from, because FScript defines description for all of its objects, and I noticed that I was getting into weird infinite loops and stuff. But if you look here, oops. So here what I'm doing is loading I'm loading the Gemstone Git as a bundle, which you can dynamically load frameworks at runtime. Creating a new connection. Connecting to it. And then I fetch the inventory, and I have the whole inventory sitting in fscript. So what I have is a Smalltalk, which is fscript, built on top of the Objective-C runtime, proxying all of its methods over the network to a Gemstone instance, hence the Smalltalk sandwich name. This amuses me, and I think that I would hope that Apple's going to get something more real Smalltalky in their environment instead of Objective-C, but the truth is they probably won't. They're probably very happy with Objective-C. But this does show you that the runtime is capable. The runtime is powerful and flexible, and you can add classes at runtime, and you can do all of these sort of advanced things. And I think I'm done. Yep. Questions?
Have you looked at Mac Ruby at all?
No.
I'm not familiar with the details in depth, but it's essentially Ruby running on the Objective-C runtime. So you could end up with
it's an actual different. It's a Ruby interpreter that. Sorry, I don't understand.
Yeah, it's.
Or is it a bridge to Objective-C from Ruby?
No, it's more of a Ruby compiler that takes a Ruby script and compiles it into, at runtime when you run the script, into Objective-C objects based on the Ruby code.
Okay. I mean, that's that.
So you can call, Cocoa objects and stuff from Ruby.
Yeah, in theory, all of the stuff that comes with Mac OS X, the Python that they have, the Ruby that they all have bridges to Objective-C, and anything that's using the Objective-C runtime should be able to use all of this stuff seamlessly. The thing that I'm mostly interested in is the persistence, and I think it's let's invent a completely hypothetical and probably a company that will never exist, but a company that has thousands of Mac desktops that are modifying the same data store all the time. With this, you can have Seaside or Rails or whatever on your front end. Your office workers are working in native Mac OS X applications. There's no competition between another scripting language that uses the Objective-C runtime and this.
No, absolutely. I'm saying. Don't worry that Apple is not interested in something more Smalltalky in the Objective-C runtime. They're doing it.
Oh, is that them?
Yeah. Apple,
okay. I didn't know that. Oh, that's cool.
And it integrates with Interface Builder and Xcode.
Oh, well, there you go. So yeah, we have it, guys. We have our solution.
Thank you. I have two questions. One, does it also work on iPhone, iPad?
In theory, I have built it using reference counting and avoiding Objective-C 2 features. So in theory, it should run fine on the iPhone and the iPad. If Gemstone would like to compile their GCI library for ARM, then I can test it. I just need the library. I don't need the... The difficulty is that usually what you end up doing, and especially here where you're going to be sending a lot of messages back and forth between your application and the gem, it's better not to use RPC. It's better to have the gem process embedded in your process. It's going to be a massive performance gain. On the iPhone and the iPad, that's probably a bad idea because of memory constraints and because of a slow CPU. So you would want the gem to be on the server and talk to the gem over RPC, but it should be doable.
And it fits with the license model
BSD.
for Glass?
It's open source and BSD. This stuff?
It says his is BSD, which is the Berkeley license.
It's the Berkeley 2 clause license, which from what I read is basically MIT. It has the same restrictions. It basically says if you break it, it's not my fault. That's the main clause, is that I'm not responsible for whatever it does to your life. But you're free to get it and use it. It's up right now on Bitbucket, which is Bitbucket? Yeah, the Mercurial online hosting, and you can go and grab that online right now. and then ask me how to build it because it's not obvious. More questions?